Good afternoon, everyone. Welcome to the talk, Testing Data Pipelines by Amitosh Swain. Uh, the stage is yours.
Good afternoon. So, yeah. So, how many of you are data engineers here? Okay, quite a lot. And how many of you can relate to this slide? Oh, that's actually quite a lot. Okay, so then we all have been there. So, yeah, this is what I'm going to tell about how to test your data pipelines. I work as a data platform engineer at Topline, like we're a small company that provides analytics for sales and marketing. Apart from code, I love to ride bikes, both motorbikes and your regular human-powered ones. And I paint a lot. And I'm active in Python and Node.js communities. Yeah. So, like, like when I joined Topline, it was like a one-person team. That was just me and my co-founders. So I'm just telling the story of how the data engineering team come into existence at Topline. And at least everywhere where I've seen, the story has been very similar. Like you have like a bunch of stuff that you write, like some ad hoc scripts that you write, and one day you decide to stick it in Airflow, and now you have a data pipeline. And everyone loves that the data that you brought, and you get more and more and more requests. And then finally, your upper management decides that we need a data team, and till now you have like a spaghetti of data pipeline that has been running for like days, months, years, and you get to inherit them. Plus, now you also have a team. And this is how your pipeline looks like. Like at this point, you know it works, but you're not really confident how it works. And now that you have a team, you want to do some awesome stuff with it. You really want to test stuff so that you don't really break anything. And you want to refactor. But you really cannot trust how data comes to you. And now everyone just says you should start testing. Especially people with like, a software engineering background, they will come and tell you, okay, hey, do TDD, do BDD, do unit testing. But actually doing any of them, like if you can relate to all the slides that I've shown before, is actually really hard. And yeah, that's something that I've been doing for the last like couple of years, and I'm going to tell you all about that. Yeah, so let's get started. Yeah. So my examples here are going to use Airflow, but whatever I'm going to talk about are generic enough, so you can apply to whatever other tool that you're using. So yeah. Yeah, so this is something that I really invented out of thin air. So data pipelines are a little special. Like they need to be tested not only while you are writing your code, but also while they're running in production. So like the production stuff is mostly called as data quality checks, but that's testing regardless. And the rest of the stuff is similar to how you do testing in like a software SDLC world, but yeah, like there's a little bit of flavor into each of the tests that you're going to see. Yeah. So if you do not have any tests, then or you just have a very basic set of tests, then I will highly recommend that you start with automated end-to-end testing. It's relatively low effort, and you get to touch a lot of moving parts. Like you can simply take a snapshot of a known good state, run your pipeline, and see if you produce same or similar results. You can cover a lot of surface area with this. You will test the components in your system, like orchestration layers, if you're calling Spark, or your warehouses, your SQL queries, everything you can test. Like you need to do a little bit of infra setup, but it's going to give a lot of benefits right out of the box. It's a little slow, it executes everything, and it's also costs you real money. So those costs, if you're not very careful, can actually shoot up real fast. And if you do some stuff like EUID or daytime stuff, you still need to figure out like how to handle them during your testing. Yeah, so let's see how you can do that easily. So simplest way would be just to make tests the part of your pipeline. Like, add a little Airflow task that runs only in a test environment. Like once you set up your test environment, you can render a task at the end that does some assertions, like yeah, but yeah, for that you need to configure some alerting that says, okay, hey, a pipeline has failed, so your test has failed. Like the idea is basically you take some raw input data, run your pipeline, let it do what it does, like running queries, doing some ETL, compute stuff, and then compare it with like, some output that you have verified earlier. You can run a select except. There's a nice little library called data diff that I really love. It can help you to compare table outputs to something that you have computed earlier. Uh, if you are operating in a data frame world, then Pandas has a testing module that helps you with assertions of different shapes, kinds, data types, and also like there is also Panda like pd.assert for something quick and dirty. So yeah, so this is how you can do end-to-end testing. And but end-to-end testing has this little problem. Like you basically took the snapshot of the data right at the beginning, or like whenever you authored your test. But data, as you know, is like very fluid, I'll say. Like it keeps on changing, like the shape changes, the data type changes, like there are a bunch of new columns that can get added, your schema can change anytime. So a small variant of what I really love is about doing snapshot testings. So what you do is like you set up a task that simply takes few sample snapshots of few hundreds or few thousands of your production data. You store them somewhere, you clean them, remove PII, remove any other temporal columns that you might have, and you can run it against your current deployed version of your pipeline. And once like you have the results from your pipeline, you store them back. And next time when you're trying to release a new version, then what you can do is like you can run your new code against the snapshot that you stored earlier and then just compare it against the version that was generated a little before, like the previous release. And most of the time, if you have made some like structural changes to the output, the snapshot will obviously vary. But if you are making some refactoring or you are just switching some libraries or upgrading stuff, the snapshot can really help you quickly validate that the data that you have is the pipelines that you have is actually running as they should. So yeah, and like there are a lot of sampling techniques that you have. Like you can do a random sampling, you can do some Gaussian sampling. Like there are a bunch of sampling techniques that your warehouse or your ETL tool will be providing. You can use it, you can store it somewhere, and then you can run your snapshot testing. It's a concept that I borrowed from front-end people. Like they like to do snapshot testing with React and a lot, and we also felt that doing the same thing with data pipelines is also really great. Yeah. Next up would be once you have set up a nice end-to-end testing, but they are little slow to run. So we have something called as functional testing. What we do there is like it will help you to run a group of tasks in isolation. We don't have mocks, but we execute code as if your orchestrator is going to execute it. It's faster and it's cheaper than end-to-end test. And since you have a lot more control over the input and output, you can you can catch a lot more errors with this. It's still not as cheap as something like a unit test that we'll talk later, because it still invokes calls to like real resources like a Spark cluster, and it will also run queries on a warehouse. And for that reason, you will also need to be a little more careful in how your pipeline code is actually authored. Like you just need to be sure like it's not super coupled with your orchestrator framework. Like if you have like all of your DAG code is in a single file, or like all of our DAG code is interacting a lot with Airflow internals, then you might not be able to do functional testing that effectively. So you need to put some effort in separating your code out. Yeah, so it's like the second step after you have end-to-end testing. So like once you do these kind of refactoring, you don't really break something. So yeah, so you need to do this after that. Yeah, like when I do this for an Airflow lag, I would want like my classes and modules to be separate in a separate file, and there are well-defined entry points where I'm calling it from my Airflow. Yeah, so yeah, the fundamental idea that we have is like we'll set up some test harness like in Python, like we have like PyTest, unit test, or something else to execute pipeline code in very small groups. We'll be providing a very known input, and we will expecting it to result in a known output. Just like we do in our end-to-end test, we will use data diff or run some SQL queries, or simply Python assert to just compare the output that is coming. Now, since we are covering a very small area, you can create a lot more cases of input data, especially for different inputs, like intermediate steps in a pipeline. And they don't have to be big. They have to be like 5 rows or 20 rows with 5 different columns with some different variation of data that trigger different cases in your code. And also, since you now have a test harness, you can use other tools in the Python ecosystem. Like we have coverage 5 for code coverage, hypothesis for property testing. You can have PyTest reports. You can put it in SonarQube. You can do a lot more analysis on how well your, your data pipeline code is now tested. Yeah. And once you have your functional test, I have this small example here that shows how to do this. It's a intermediate step in a ELT that we do at Topline. We are trying to extract some properties from a HubSpot table. We have this Snowflake executor here that basically is an abstraction over Airflow executors. We have set up some test data with it's just one line, there's one row that I'm doing because a very small test. And we now execute this thing, like line number 10 and 11 is like when we execute the task that we have, and it produces in a single row. And I am just simply fetching it from a pandas, and I'm checking whether, my data is actually correct. It's a very simple toy example, but yeah, you get the idea. Like you run the code, and then you fetch it off, and then you just compare it against. And yeah, there's pandas testing as frame assert equal just helps you to compare your code, like whether it's expected or this what's thought. Yeah. Now we see what we do with unit tests. Like I assume a lot of you folks are actually familiar with unit testing because data pipelines at the end is just code, so you can just treat it as a code that you're testing. They are quick, they are focused. They use mock dependencies, and they're actually cheap to run, and they help to test the concept behind the entire pipeline as code thing that you're doing. But remember to be careful because mocks don't really behave like the real thing. So sometimes you might write a unit test, but then you put it on the production, and then you think, okay, hey, my server is not expecting this particular input. So be careful with unit testing. But it really helps to find out orchestration logic bugs, or if you are trying to have like a conditionally rendered task, then in this case, unit testing is really helpful because you can have like a lot more branch coverage, lot more line coverage with it. Like you can test different clauses, different inputs that you have to do it for the pipelines. Yeah, like to write unit test, you just write regular Python code in unit test or PyTest. You need to make sure that your pipelines are small chunks of Python code, or else your unit tests are going to look like very large files. So yeah, and it's really important that you separate your orchestration from your pipeline logic. You can do various conditional steps, like you can compare your DAG structure, you can assert what tasks get involved with what arguments, you can check various conditional steps, or you can see how your orchestration layer is behaving with a particular set of data, but with the data, the data shape is actually being mocked by unit tests. So yeah, there's a lot of things that you can do with just simply unit testing. Yeah. And here's an example of a simple unit test. What I'm doing here is I'm rendering an Airflow task with some arguments as it would have been invoked by my Airflow DAG. And I'm trying to check whether my SQL query is being constructed as we expected. It's a variation of the same task that I was showing earlier. Again, it's a sample from our code base that we do. And yeah, there's a helper function called SQL compare that does like a semantic comparison of SQL. Like it tries to parse it and then compares it. It's a little internal library that we wrote. That's unfortunately not available here, but yeah, you get the idea. Now we talked a lot about how we're doing testing during SDLC, but for data pipelines, since data is really unclean and unpredictable, we don't stop there. We actually go and test in production. I mean, it's not like testing in production when we say testing in production in other contexts. It's more like monitoring in production. And like when you are writing your pipeline code, we usually have some assumptions on how our data is going to look like. And sometimes our pipeline will just break down if your data does not adhere to those assumptions. Yeah. So having a strongly consistent data model is not really possible at scale. Like you cannot use things like constraints and checks, foreign key relationships, especially when dealing with a big data. So for that, we need to have something else that guarantees this data quality. Yeah, and in order to actually deliver value to your users, your end users, your consumers, they must be able to trust the data that your pipelines generate. And if you can't guarantee that our data model is consistent, then it's not very useful to us because their analysis will go off, the reports will go off. So it's really important that whatever data that is generating is actually for the best possible. It's like we need to do a very best effort to have the data to be very accurate and very clean. Yeah. So we commonly call these things our data quality checks, but like I really like to combine them with testing because there's just a lot of overlap. So the idea is just to make sure that your pipelines are generating correct outputs semantically. Like, is the data model consistent? Yeah. Are the key references valid? Are all invariants are expected? Like if you expect like a data to come in a particular shape, is the shape being respected? If the data to be a particular data type, then if you have a data dictionary that you're maintaining, are you maintaining the dictionary consistently? Are you sanitizing everything? Do you have unexpected nulls or do you have duplicates? You can write like a bunch of SQL queries to do all these checks, and we also have a lot of statistical checks that we can run, like checking the distribution of data, like do you have unexpected rows for a particular country? Do you have unexpected rows for a particular value? Need input and output rows checked drastically. So these are all questions that you need to account for when you're doing data quality testing. Yeah. So you can start like very simply, like with data quality. It's like, again, just like we were doing end-to-end testing, we'll add a new task, but this time this task is actually going to be executed every time my pipeline is going to run. We can call this like a validation task, and we will be validating our data models. We will assert our invariants, like all not null checks, duplicate counts, and we'll run some statistical checks. Sometimes you might want to test something outside the pipeline, like maybe you want to check whether my pipeline has processed all the new data, like is my pipeline not stuck? Like sometimes you might have this false alerts from pipelines. Okay, this pipeline is successful, but it's not actually processed all the new data. And also while checking for distributions, input and output, it's also good to have like a view of your data from outside the pipeline, because you now have like an entire picture of what happened yesterday, what happened today, what happened tomorrow. So you can do a lot of stuff there. And if you're trying to implement data quality testing, there are a few great tools out there in the open source world that we love and we use. So Soda Core is a nice composable format for data quality especially. They have this YAML-based format called Soda CL, so that you can just describe what you want and you run it against a data source and it works. And there is also something called as Great Expectations. It's a little bit more involved framework. Like it takes some time to set it up, but once you have it, then you have some nice like reporting and monitoring that you get out of it. Yeah. So now, what do we actually do at Topline? Like I'm just talking about a lot of things, but I'll just walk you through what we actually do there. Now we have to process like several terabytes of data every day from different customers, and having inaccurate data really has like business implication for us and our customers. Like our customers are going to run like their sales and growth strategies, so their revenue generation is directly going to be impacted if we process some incorrect data. So it is really important for us to do like things in a really correct manner. So this is what we do at there. Like we make sure that like it took us like around 6 months, but we now have a good enough abstraction on Airflow. Our data pipeline logic is now based on that abstraction. We love to call it as DAG line. I'm in the process of open sourcing it. Maybe somewhere down the like 3 months we'll get it. It has some nice more additions to Airflow. Like we unit test every components of our pipeline, and like we have got functional tests that run before code merge and end-to-end runs for every pipeline deployment. We have like a harness that also runs snapshot testing. That's also like the framework that I'm also looking if I can open source it, but yeah, no promises on that. And for data quality checks, we have something called as Litmus. It's a in-house framework. It's built over Soda Core and Great Expectations, and we use it to run data quality tests on demand, like our pipelines. Once they have completed a check, they basically trigger this, and it runs asynchronously. And if something goes wrong, we get an alert like something is broken. And we can configure it to run things on schedule, like you want to check for data, like data has arrived today or not, and all those things. So yeah, so that's all what we do. And yeah, so I have like around 5-10 minutes for questions. So if you have any questions, I'll be answering them.
Hello. I love data. I don't like making up data for my unit tests,
Yeah.
even when it's 5 rows, right? Because once you have like 100 things, that's 500 rows. I guess, could you talk a little bit more about how you generate that data for some of those data-specific tests?
Yeah. So like for data specific tests, usually we do like some napkin math and figure out, okay, what is happening. Most of the time it's in response to a bug that we have found in a pipeline, or some pipeline has failed or something. So we know what is actually causing it. So we use it more like a development aid than actually generating it. But we do have some scripts that we use. Like one of them just simply goes and samples like some 200 rows from an input like table that we have, and then we drop certain columns that we have. We run some checks like whether the data is actually correct, and then we do it. And many of times we actually write data like by hand, but that's not very common because, like as I said, like most of the time the data that we have is in response to some bug or something that we have found earlier. I mean, there's no clear-cut way of generating data from like some autom. And also, we have something that we use. It is a combination of Faker and like some like random libraries, like random generation libraries. We use it more in a perf testing scenario, but we don't use it for unit testing right now. But we can very well plumb it into this setup. So, any more questions?
Hi, thanks for the talk. Have you had any issues with cloud costs or any other extraneous costs from running tests in production? And how do you keep costs low with running tests?
Oh, we actually have so I just tell a story like around maybe a year back, like our testing Snowflake account was giving like $20K bills, and we were really shocked about this number. Like, where did 20K come up? And turns out that we had some inefficiencies in the way our tests were running, and yeah, we actually had like bill shocks. So what we do currently, we use a lot of like quotas for running tests. Like a Snowflake account itself has like a daily and monthly spend quota, and you really need to go and see if there's a breach in quota. Like Snowflake has this feature that we use it. Also, we have quotas on the AWS account that you have, like we have some billing alerts. And there is also some runner minutes that you have configured in GitHub. So so that we have a check on how much, like how much money we are actually burning on testing. Yeah, but that has actually happened. Like we have burned our fingers a couple of times with testing bill actually going a lot higher. Yeah, so thank you. So if you have any more questions, you can find me out on Twitter, LinkedIn, GitHub. Like here's this big QR code you can scan, get connected. Yeah, so thank you. for this opportunity.